In this video, we are going to learn how to find the inverse function of a trigonometric function. So our instructions will be to find the inverse function f inverse of each function f, which will be given, and find the range of f, and then the domain and range of the inverse function. Now what's nice is I'll be given the domain of each function. That's why we're not finding the domain of f. I'm going to give it to you. So next up, I'm going to be given f of x equal to 2 sine of x minus 1 on the domain of negative pi over 2 to pi over 2. And then I'm going to change f of x to y. So finding an inverse is the same as switching the x inputs and outputs. So whatever was the input of one becomes the output of the other, and vice versa. So that way they are going to be canceling each other out. So first I'm going to interchange the x and the y. So now if x is equal to 2 sine of y minus 1. Now I'll just proceed to solve back for y, which means I'm going to undo all the math, all the operations happening to sine 2y right here. So first I'm going to add 1, so I'll have x plus 1 is equal to 2 sine of y. Then I'll divide by 2, so I'll have x plus 1 over 2 is equal to sine of y. And then I'll take the inverse function, sine, to the other side. So y would equal sine inverse of x plus 1 over 2, which this will make up my inverse function. So to finish out the problem, I'll just put f inverse of x is equal to sine inverse of x plus 1 over 2. And that solves that first part of the problem. Now I want to find its domain and range. And the way to do this is actually to find the domain and range of the original function first. So the way I'm going to pull this off is I am going to take this equation and solve it for sine of x, because I know the range of sine of x. It's between negative 1 and 1. So I'm going to solve this for sine of x, and I'm learning that sine of x is equal to y plus 1 over 2. But now that I have this expression, what I can do is put that in between negative 1 and 1. So negative 1 is less than or equal to y plus 1 over 2, which is less than or equal to 1, and finish solving that inequality, that compound inequality, by multiplying each side by 2, or all three parts by 2, which gives me negative 2 is less than or equal to y plus 1, which is less than or equal to 2, and then subtracting 1 from all three parts, giving me negative 3 is less than or equal to y, which is less than or equal to 1. And that's my range for this function, which is really nice. So if I write this down, I know my domain will be brackets negative pi over 2, comma pi over 2. And the reason why I'm using brackets is because these are equal to up here. I'll also use in brackets again with negative 3 to 1. I'm using interval notation. And now to find the domain range of the inverse function, since I switched the x's and the y's for the f function, I'm just going to switch the domain and range, which represents the x's and the y's for that function. So now the domain of f inverse, what can I plug into this function for x, would be from negative 3 to 1. And the range of the outputs I would get would be between negative pi over 2 and pi over 2. Let's try another example. So up here, I'm going to first rewrite this as y is equal to negative 2 cosine of 3x. Interchange the x and the y, so x will equal negative 2 cosine of 3y. And now I'll solve for y by dividing each side by negative 2, giving me cosine of 3y is equal to negative 1/2 x. Now I'll take the cosine inverse, give me 3y is equal to cosine inverse of negative 1/2 x. And then I can divide by 3, and that'll give me my y. So f inverse of x is going to be equal to 1/3 cosine inverse of negative 1/2 x. So that'll be my inverse function. Now I know what the domain of f is. It goes from 0 to pi over 3. But I need to find now the range of f. Again, cosine is also another function that's between negative 1 and 1. And if I change the period, we've already learned before that the period doesn't change the y value. So even cosine of 3x would still be between negative 1 and 1. So what's helpful about that is if I solve this for cosine of 3x, I can see that cosine of 3x is just equal to negative 1/2 y. So this inequality becomes negative 1 is less than or equal to negative 1/2 y, which is less than or equal to 1. So perfect. Now I can multiply each side of my inequality by negative 2 to get rid of the negative 1/2, making this 2. But now that I multiply by a negative, I have to flip the inequality. Now I have y, and again, flip that inequality because I multiply by a negative number, and that becomes negative 2. And I can rewrite this to be a little more clear, because now this is negative 2 is less than y, less than or equal to y, which is less than or equal to 2. So my range becomes negative 2 to 2. So now the domain of f inverse is negative 2 to 2. And the range of f inverse would be 0 to pi over 3. So I'm just going to switch the domain and range of the original function. So next up, I'm going to find the inverse function of 2 tangent of x minus 3, which again, same first step. Y is equal to 2 tangent of x minus 3. Interchange x and y. So now x is equal to 2 tangent of y minus 3. I'll add 3. Then I'll divide by 2. Give me tangent of y is equal to x plus 3 all over 2. And then taking the inverse tangent of the other side, I can see that my inverse function, now that I've solved for y, is equal to tangent inverse of x plus 3 over 2. The domain of f is going to be negative pi over 2 to pi over 2. But the range is going to be something different. Because now I know that tangent by itself, its range is everything. Negative infinity to positive infinity. So even if I solve for tangent here, which would tell me that tangent of x is equal to y plus 3 over 2, because I'm dealing with infinity, when I multiply by 2 to get rid of that, the infinities don't change. And when I subtract by 3, those are still infinity. So my range just remains negative infinity to infinity. And something that's really nice about dealing with tangent functions, because that range shouldn't change no matter what kind of transformations you may put on the function. So now the domain of f, I can plug in any x value I want into this. Because again, any number could go inside that tangent inverse function. So negative infinity to infinity. But the only angles I'm going to get out of it will be from negative pi over 2 to pi over 2. And I did make a mistake because I put brackets at first. But it never equals pi over 2. So these would actually be parentheses over here. And that is how you find the inverse function of a trigonometric function.